This is question number 15 on the June 2014 calculator paper. So let's look at the question. The question says, diagram shows the positions of three turbines, A, B, and C. So let's have a look. A, B, and C. Those are the positions of three turbines. A is 6 kilometers due north of turbine B. So A is 6 kilometers north of turbine B. C is 4.5 kilometers due west of turbine B. And there's C, it's 4.5 kilometers away. Calculate the distance AC. So we want to work out this distance over here, AC. Okay, you should be pretty familiar with this so far. You've got a right angle triangle, you know two distances, two sides, and they want you to find this side, AC. You should realize at this stage that you do need to use Pythagoras Theorem, right? And you want to work out the side opposite the right angle. That side is the hypotenuse, and as a result, we're going to do S, S, A, S, square, square, add, and square root. So let's have a look at this. I'm going to do the workings in the space below. The sides that I know are 6 kilometers and 4.5 kilometers. I'm going to square, square, add, work out my answer, and then square root it, and that will give me my result. So I'm going to use my calculator for this. I'm going to work out 6 squared plus 6 squared plus 4.5 squared, and then square root my answer, and that's going to be 7.5. So let's just go through that again. 6 squared plus 4.5 squared. The answer to that is 56.25. I'm going to write that down. Square root 56.25. And as I did before, square root 56.25. And that gives me 7.5. I'm going to put that in the answer space, 7.5, and there's my result. Okay, this is a pretty straightforward case of using Pythagoras Theorem. You should be familiar with it, and you should be able to do it and get full marks in it. Okay, what we're going to do now is look at part B. Part B says, calculate the bearing of C from A. Give your answer correct to the nearest degree. So we want to work out the bearing of C from A. I'm going to go back to the diagram at the top. I'm going to do the workings all around that, so to avoid having to move up and down between them. So from the question in part B, they wanted us to work out the bearing of C from A. Because it says from A, this is where my bearing is going to be taken from, and they've given us a hint by drawing this north line. Right, if that wasn't there, I'd need to draw it anyway. Okay, a bearing is taken in a clockwise direction from the north line, and that's the bearing that I need. This angle on this side here up to this point is 180 degrees. So I just need to work out this angle, angle A in the triangle, add it to 180 degrees, and that would give me my whole bearing. So if I call that angle X, I need to work out angle X. I'm going to use trigonometry for this, and if you remember your trigonometry, it means I need to use SOHCAHTOA, S-O-H-C-A-H-T-O-A. Okay, relative to this angle X, directly across from it, 4.5 is opposite. We know this side is the hypotenuse, so 6 must be the adjacent. I know this is 4.5. I know the adjacent is 6. I've already worked out the hypotenuse, but in this case, I don't know it on this triangle, so I'm not going to use the hypotenuse. I'm going to use opposite and adjacent. And if I look at the three trig ratios, that has opposite and hypotenuse, that has adjacent and hypotenuse, and that has opposite and adjacent. So I'm going to use this ratio, the tan ratio, to work it out. Because it's an angle I'm trying to find, I'm going to use inverse tan. And I know the inverse tan is opposite over adjacent. Opposite is 4.5. Adjacent is 6. So I just need to work out that value. If I get my calculator, and I'm going to do shift tan, and that's how I get the inverse tan. I'm going to put a fraction in there, and 4.5 over 6, close the bracket. Here is my answer, 36.869, and so on. And to the nearest degree, that's going to be 37 degrees. Okay? I need to realize that this angle at the top here is 37 degrees. So the whole bearing, so the bearing of C from A is going to be 180 added to 37. So I'll write that over here. The bearing of C from A is going to be 37 degrees plus 180, and doing my maths, that's 217 degrees. Okay, I could write that in the answer space below, and if I was doing this in an exam to avoid me moving up and down between the two, I would have done all the working in this space, and the answer I would have put here is 217 degrees. This is a challenging question. It's one of the more challenging questions in this paper so far. Make sure you understand it. Make sure you can do it. Make sure you get your head around bearings.